Good morning. So I guess everyone can hear me. Welcome to Cloud Architecture for the 80%. My name is Dominik Wagenknecht, as already said. I'm from Accenture in Vienna. I think. Is it working? I had some strange sounds. Anyway, still sounds right. Okay. So I'm doing cloud architecture out of Vienna. Drove over in the morning because sadly enough I have a sick kid. So I have two girls. I'm totally outvoted. 15 years in the game. Got some cloud certifications, especially in Azure. I have like the highest solution architect certification, and within Accenture we have this MTA program where I also reached the highest one, which is essentially the reason why I'm still doing consulting after 15 years, because it's pretty nice stuff. So, some core assumptions about this talk. And it's a bit weird, right? Because I'm at a conference explaining you in a conference talk that you shouldn't do architectures based on conference talks. But some core assumptions. So you're not Netflix, you're not Google, you're not Meta, you're not building some new world-spanning ad network, you're not building the next AWS, you're not building the next Fortnite or any MMO for that reason, right? You're not building a new CockroachDB or Fauna. You don't have like 10 math PhDs sitting there and doing real scientific stuff, and that you then have to present at conferences and so on and so forth. So the core assumption is you're just a normal company with customers who wants to get stuff done and compete. And you need a home, you need a platform, ideally in the cloud, right? Because you don't want to install your own boxes to develop your stuff on, and essentially back your SaaS, right? Because you're building this fancy new SaaS service. So here I am, and here's your developers. And they go to conferences, right? And they look at blogs, and there's shiny new things. It's amazing, right? And these are pretty up to date. So there we have Timestone. That's awesome, right? It's the new high throughput, low latency priority queue system from Netflix. That's got to be awesome. We got to check that out. It's so easy. It just needs Elasticsearch, Kafka, Flink, and Redis, right? And off you go. And you can just install it on your Kubernetes cluster and everything will be fine, right? Or we have Meta's new cloud gaming infrastructure. I mean, that should really be the foundation for your new, I don't know, do you do hair salon data arrangements? You really need that backend. Or the new eBPF agent for infrastructure observability. Well, that strikes all your tones, right? eBPF, you can program, you can run your own code within the kernel, in the packet filter. I mean, that's the shit. The thing is, in the cloud, it's possible, right? It's possible for mere mortals. Because in the past, you would have had to buy a ton of boxes. But here it's possible. And you do not need to wander endlessly through Middle-earth. You just punch in a credit card. You throw on it a bit of Terraform, CloudFormation, or whatever you fancy or what the project has. Then you add some Helm charts. You maybe put in a custom CNI, right? The eBPF goes really deep into the system. So yeah, you need all of that. And next stop is obviously Nirvana, right? Everything is fine. Or maybe not. Because you're responsible for what you run. You're responsible for all that stuff that you're installing. And maybe you realized maybe it's not a great idea to install your own eBPF agent. I mean, you then call Google and you say, hey, I have some problems with my network communication. And they are like, duh, I see you modified in the kernel the packet routing. Well, is that our problem? No. So let's start really small with a container. And there it gets interesting because people have a lot of false assumptions about what it means to run a container, like actually, right? So let's do the standard case, right? You run an ad on Kubernetes. So you go to Google, you put some GKE together, or you put some EKS in AWS, or the AKS in Azure, right? Here's your container. You put it on there, you have your Kubernetes right there running. It's managed, right? So you don't have to do anything. So that's good, right? So the green area, you don't have to care about the network, you don't have to care about the storage, you don't really have to care about the machines. But the line in there is not a mistake. Because actually, if you read the fine print, you're in a shared responsibility model. Because you can install whatever you want on Kubernetes, and you can do a lot, right? You can run with root, you can access the nodes, and so on and so forth, with exceptions. If, for example, on Google, you activate the autopilot, then you lose that kind of ability. But in most cases, it's possible. So you're in a shared responsibility. That means that if you run into problems, you probably have to deal with it. And you have to go into the... So support will not necessarily solve your problem. So that's the easy part. But then comes the next part, right? As of yesterday, I updated that, right? I don't want to make any false impression. Scanning the OpenJDK version 17, latest patch release, standard base image. Well, it has a lot of open critical problems. You're responsible for that. It's your container. If someone hacks into that, your problem, right? Like 100% your problem. You have to keep that stuff up to date. It's your responsibility. And here we're just talking about a simple container. If you do something in the space of data analytics and so on, and there's suddenly a full Python distribution in 3 different versions because someone is still stuck on 2 point something and the other one on 3 point something, you will have a gazillion of things that you are responsible for. And there's then this interesting aspect that if you switch to a different platform, the game is a little bit different. If you, for example, run your app on Lambda, then suddenly you're only responsible for your code and the libraries that you use in there, because they take ownership of the language runtime. And that's, I mean, Lambda is like the most known one from AWS and so on and so forth, but it's the same principle all along. And you can read up about it, right? It clearly says in the AWS documentation, Lambda is responsible for keeping software in the runtime and execution environment up to date. So if there's a patch release of Java, they have to run it, right? Releasing new runtimes for new languages and frameworks and deprecating runtimes when the underlying software is no longer supported. If you use additional libraries with your function, you're responsible for updating the libraries. So the NPM dependencies, the Maven dependencies, still your problem, right? That's kind of manageable. Now, of course, a lot of people are then, oh, we're the cool ones. We run our own custom runtime. Guess what? It's suddenly your runtime. I think it was Mike's sound. Okay, so that's then suddenly your problem. And you might think, well, that's easy, but right, you have this company, you have more to do. This is a complete, somewhat random collection. I could find more, but essentially, you know, all this shift left, right? So you have responsibility for the full development lifecycle. You got the job of operations, monitoring, encryption. You have to do some secure pipelines because obviously your containers need to be sound. You need the dev tooling, you need the network security, you need your dev and test environments. Well, that sounds easy, right? It's just some scripts away, but hey, you need to anonymize your production data, probably. You need to care about scaling. I forgot that in the Kubernetes case, you have to scale yourself. You have to take care about identity, you have to take care about GDPR. I have a lot of banking background, so there's a ton to do right there. So there's work, right? And if you take something away from this call, there's a lot of work. But now, within your 80% company, within your SaaS that you are building, and you want to, I don't know, get famous, get rich, or I don't know what, what's the most expensive and least scalable thing? And Bratislava is pretty sold out. It's engineers, right? So what should they do? They should solve real problems, right? Hence, I think it's completely underestimated how important it is to make things simpler and reduce the cognitive load, because otherwise those poor guys have to think about all of that, right? And that's a lot of work. So those things happen on many levels. And here's the real point where essentially cloud in its whole collection of things makes a difference. And it's just like in normal life, right? If you have to do real big challenges, like kids, you gotta find a partner, right? And now you can choose. It's pretty arbitrary that there's 3 up there, and you can find out for yourself who is, right? Some are more new, others are a bit more serious. No one knows, they're laughing, right? But the point is, it's like a marriage, and you get the good and the bad, and your partner evolves independent from you, right? So on each reinvent, your partner will tell you what new tricks he learned, right? And what tricks he maybe doesn't like anymore, or whatever, right? So it's the full package, but it's the full integrated package. And that is a pretty useful thing, because, for example, if on Kubernetes you go all crazy, right, and you install your own open policy agent and so on and so forth, you have to run that stuff. And in here, it's kind of solved. Stuff just works together. And let me give you an example. If you run a workload on all of the 3 big public clouds and also on Alibaba, and then it kind of breaks down a little bit how well all of that stuff is integrated, then you run a workload, be it in a functions or in a Lambda or in your Kubernetes, and it has an identity. And through that identity, you suddenly solve a big problem, namely, how do you manage secrets in your development lifecycle and all that kind of stuff? Because through the identity, that system can automatically access the secret store. And it can automatically access the managed databases, the storage service, whatsoever. Roles and rights are automatically applied. That's pretty nice if the auditor comes by and wants to see a list who is actually allowed to do what, right? And you can like very easily go in and make sure that within your fancy architecture, the BFF, so the backend for frontend, that doesn't have state, doesn't have access to a database, but then the microservice it calls does have access to the database and only to the right one, and so on and so forth. That makes life kind of simple, right? And policy is also applied. What does policy do, right? Policy manages usually things like, and every one of the big clouds calls it a bit different, but in there you encode rules like, we're really running in West Europe only, right? No, please don't install it in the US because we put this GDPR thing there. So you enforce those things. So you can essentially give your developers full freedom because the policy will make sure that they don't do super stupid things, right? Which is good, makes life simpler, less processes. And this breaks if you do a lot yourself, because of course, if you run your own Kafka on the managed Kubernetes, then Kafka is not managed and is not integrated in the identity thing. If you run your own Kubernetes environment and essentially strip down the cloud or your partner into a dumb data center, infrastructure as a service, because you're suddenly just consuming VMs, then again, it is not integrated, right? So that's the beauty when things essentially fit together and are under one house. That's also why I put up this marriage story a little bit, right? It's a long-term relationship, for better or worse. And third-party offerings are often also not covered, right? So we have to adjust our thinking a little bit, right? They rest in this big theme of essentially saying we do best of breed. And I mean, Accenture is a system integrator and a big consulting company. I have done a fair share of comparison PowerPoints, assigning Harvey balls and what's essentially the best solution, where then bad decisions have been made. But it's many years ago, yeah. Some products were cool, or at least we thought so. So best of breed and just going for the hottest, most shiny thing, or the one that you like the most, is maybe not the smartest way. It makes more sense to essentially say best of platform. And if there is a real value in doing something different and breaking out of it, because there's a real insufficiency or you really gain something from it, you have an utility out of it, well, of course exceptions apply, right? Of course. So is this all good? Solved. Done. Presentation done. We're early. It's brilliant, so I can let you out. Anyone have any thoughts? What could be bad about this? Cost? No, it's pretty good, actually. You're not paying any egress fees, right? It's all integrated. But then usually, especially in big companies, everyone will say, ooh, that's this dangerous thing we read about. It's lock-in. right? We should do something so that essentially we can leave our partner. It's like it's a funny thing, right? But essentially, financial institutions, for example, need to have an exit plan, right? If you're a bank or an insurance, you need to write an exit plan, right? You need to have a strategy written down that essentially says, how am I going to get out of that cloud? It by the way, also applies to any provider. So if they are dependent on a provider, they need to provide an exit scenario, right? It doesn't need to be from yesterday to tomorrow. It can take like 6 months. So that's not a problem, but you need to get out. So there's this thing that is called lock-in. And everyone here in the room intuitively knows it, right? Like, should we really build our full enterprise on this niche little database that only 3 people know and that has a data model that no one else uses? Well, maybe, if it's very unique and it has a huge advantage for us, but maybe not. So to keep things really, really simple, some orientation, and there's way more ways of having a lock-in, right? But let's keep it really simple. So the traditional classic one is a product, technology, or vendor lock-in, right? So you have an Oracle database on-prem, right? And every few years, you will come into a budget discussion with Oracle, and yeah. And at least you run it yourself, right? So they cannot remotely turn it off or something like that. But still, it's also not feasible, right? You have to run updates. You have to keep the system somehow running, right? So you have some long-term cost in there. This also applies, by the way, also to open source exposure, right? Of course, it's different because you don't pay directly and you have more ease in switching, but you have to find someone who essentially keeps the open source up to date for you. I'm going to talk about cloud platform lock-in, like the foundations on which you build stuff. A very similar, but I'm keeping it separate on purpose, is the SaaS lock-in, right? Like something like Salesforce or Workday, where you really have all your data in and you cannot really access the database and say, select star and now let's dump it down, right? You can't do that there. You can do it in the middle. So what about that, right? So you now decided, I don't know, do we go for the cleanest cloud Google or we go to Microsoft or whatever, but you now decided for one and now you're in there, right? And now it's very important to see everything you choose, right? The database you choose, the programming language you choose, the runtime environment you choose, anything you choose, right, has a certain degree of lock-in, right? If you want to switch, it will cost you something. And then we see here on the right side, and I'm citing Gregor Hope here, who has his article up there at Martin Fowler's webpage because he used to work for ThoughtWorks a while ago. You can essentially look at kind of a matrix and say, okay, if something provides really high utility, then I'm accepting a high switching cost. Right? If you're building, for example, a fancy parcel routing system, then a graph database could be very useful. Now, switching from one graph database to another graph database is really, really hard. But if this thing gives you a benefit and your bikers run faster through the streets and beat everyone else and the food arrives quicker or the packages arrive quicker, that's a unique utility that has value, right? So you accept that lock-in. You know that you will be coding for half a year to switch away from the database. You hope for the best, right? You put it in your contracts, you accept it. It has value. If something has a high switching cost but doesn't provide that kind of value or utility, then you have a problem, right? So you're in the caution zone up there on the left. If something is easy to switch, well, then it's kind of disposable, or you can switch around it in a natural way. Brilliant, of course, is low switching cost, high utility. Containers could be such a thing, right? And also the degree to what, if you look at the code, the degree to what having something in Lambda or and grabbing it out, not that bad, right? I mean, the difference is in the one you have an HTTP server, and the other one you essentially get the HTTP request in and it's passed for you to a certain degree. So it's just the line shifting. There's not a lot of boilerplate you have to put in there to get from a Lambda to a microservice. So it should be relatively easy to get out. So on the left side, I essentially, the way I approach it, or I think we should approach it, is essentially you should look at the cost of switching. And then what many people prematurely do is they do something to ease switching, right? So you put in a software layer, some magic abstraction or some open source tool or something where then essentially you can switch from Mongo to Postgre in a breeze, or so they say. Also, those things have a cost, right? So if you switch onto a certain abstraction, onto a certain framework that essentially does that for you, also consider that kind of cost, right? Don't like prematurely jump over there. One of my most lovely examples is always Terraform, because if you do Terraform and you just have one cloud and you look into your Terraform scripts, then you will see if you switch, there's like zero reusability. Because on the one hand, you're using all these AKS objects, Azure objects, and in the other situation, you're using all the objects from Google, right? So it's really different, right? So it sounds the same, right? Because you now have this multi-cloud, multi-platform tool, but actually your developer experience gets worse. And it's hard to move. Now, if you're in a hybrid situation, you have to run something on-prem and in the cloud, then it could be a brilliant idea. So you have to evaluate it. And then you can look at financial modeling, right? The article does that as well, and essentially say, okay, I'm going to do an option, because if in financial world we've solved it, right? You have a risk, you buy an option, it has a strike price, you work with some probabilities, and you essentially say, is it worth it to safeguard against something, right? Where's my time, by the way? Oh, lost it. Not working. But you also have to consider making this dynamic, because your cloud, your partner is evolving, right? New features are coming out. And if you're dependent right now on the latest Postgre version, there's a good chance that the competition will support that Postgre version in the near future. And that's what I essentially want to show here. So there's some market dynamics and there's some healthy competition going on between the cloud providers, where essentially stuff is coming in from the right, like the really fancy edgy stuff, then suddenly everyone has it, and then some kind of standardization and so on happens. And we can also look at it in the form of patterns and standards and open source products, right? Like, for example, the application monitoring space, where essentially we now have open telemetry, has standardized dramatically. So nowadays, if you program against open telemetry, you have a fair chance that you just have to include some additional dependencies and it will work on Azure, and you put some other dependencies in and it will work on Google, like fully integrated. And the amount of change, the amount of switching cost is really not that high. It's also a good idea to use Postgre, right? Everyone has Postgre, and it's so common that everyone even has a fancy version of Postgre, like Aurora, or last week Microsoft played catch up with Cosmos for PostgreSQL, and in between, like for a long time, Aurora was alone there. Google came with AlloyDB, where essentially they provide to you a very, very scalable and nicely failover capable and so on Postgre. So there's a lot of possibilities, right? And if you see that something is gaining traction, you can take the risk, because from a market dynamic perspective, right, coming back to that, it could change. So it's not just financial modeling, it's also a bit of, right, I don't know, reading in the coffee powder. So in closing, what do I really want to communicate here? Make clear decisions and start as simple as possible, because complexity comes automatically. If you build it complex from the start, that's really, really not worth it. So do as little yourself as possible, and kind of self-restrict yourself, right? And keep in mind that you have to do a gazillion of things to really run a long-term service on something. So some purely subjective thoughts about the simplicity, right? And that's now very dependent on the flavor you're in. If you happen to be a JavaScript, TypeScript shop, then you're in total luck, because over the last few years, some really incredible nice tooling with really nice properties came up, right? If you're a JavaScript shop and you try out Vercel with some additional plugins, like for login, you use Auth0 and so on and so forth. So there's a lot of integrations. it's awesome. It's like the build pipeline is there, the run environment is there, the test environments are there. It just works. But you're in JavaScript land, right? So it's like for Next.js and so on and so forth. So that's interesting because, again, remembering right from the beginning, you don't even have to take care of your own container, right? If you wanted a little bit more bespoke, right, where it still has a bit more sharp edges, then Cloudflare Workers could be interesting. Has a lot of cool additional things in there as well, like databases and so on and so forth. If you happen to be an Elixir, Ruby, Python, or PHP shop, right, then you need a container. Still all good. Even there's some really interesting things out there, like for example Fly.io, which really impresses me how easy it is to run a container in a safe way, right? Globally. But here you now have at least a container ownership, right? If, of course, you go full enterprise, due to your size, due to regulations, due to the complexity, well, you have to dive in. But please, 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 there's nothing more stressful than having two relationships on the same time. Have one partner, right? So hello to the full-fledged cloud. You can now have fun with designing your virtual networks, your policies, your encryption, and so on and so forth, and striking a real nice balance between that. Because everyone, the network guy, will want to do the most awesome and most complex and most secure thing, and the developers will want to use the most complex and most fancy thing, and so on and so forth. So you kind of have to find a global optimum, right? Which is complex. And trust me, your partner, your cloud provider, is investing a lot of money, really a lot of money, to make your ride as smooth as possible. And it's practically impossible to be better than them at that, unless you have a lot of money and a lot of really good engineers lying around, hidden somewhere. Please tell me where they are. We're always looking for people. So there's some further pointers to deal with shiny new things, right? And sometimes they're old. It's interesting how the pendulum swings, and this now goes more into the development space. Like you maybe saw that we went from server-side rendering to full SPA, and now there's a certain swing back happening outside of Java, at least. So it's always interesting to follow David Heinemeier Hansen and Jason Fried, right? And then I put in two additional blog posts, oldies but goldies. One is Choosing Boring Technology from Dan McKinley, where he makes very nice visualizations also on how to essentially choose just a few technologies and really play it. And then there's also the idea, it's a really short one, about introducing a novelty budget. Because maybe you could tell your developers, look, you get a novelty budget of like 2 novelties. And if you use the database, then you just spent the novelty budget token, right? So something like that, right? So yes, Agile thinking, by the way, has also a lot about that. So you have these exploratory things and so on and so forth. So you can do a lot in that space. But that's really kind of my recommendation I would want to take away from this. So thank you. Right, the questions are over here. Now I will be looking at an empty screen. No. I would not consider polygamy. Right? To be honest, I mean, I'm now doing that since a while, and most really big enterprises. So the question is, if you would have to, which cloud would you marry? Azure, AWS, GCP, or even maybe Alibaba? Bonus question: would you consider polygamy? So the very big enterprises more or less automatically are in the polygamy space because they buy other companies and they happen to have another cloud or so on and so forth. But at least then you have kind of a separation, right? For example, you have Azure because there you have Office 365 and your emails and all that kind of stuff, but custom development happens over there on AWS. The only situation so far that I've seen where really you were in the true kind of polygamy space, if you want to say it that way, was at one of the big German car manufacturers, because surprise, surprise, they have telemetry data from the cars and all this assisted driving and so on and so forth. And if you're in China, then other data security rules apply, right? So you really have to keep the Chinese data on Alibaba or Tencent, and you don't want to mix it. So they have the real business reason and gain unique utility out of it to essentially being able to run their car cloud, or however you want to call it, at the same time at two different clouds, and then again against around multiple regions. So again, in that case, for example, US data is not mixed with the European ones. I hope that makes kind of sense. But honestly, I would keep it as simple as possible. But it's a huge art form, and a lot of people will explain to you like multi-cloud is the full thing, and it's the most awesome thing. And then you suddenly get sold a lot of additional solutions, like single pane of glass that do billing across all of it and analysis. So you suddenly move into a very complex space. So Oracle lately announced multi-cloud. Yes, of course, right? So you can have applications in Azure and DB in Oracle Cloud, no cost of the traffic and so on. Maybe the polygamy case sounds good in that case. Yeah. You know the market share of Oracle Cloud, right? It's relatively low. They have a very unique thing because it's the only place where you can run big Oracle workloads at scale. So it's a good idea to go to Oracle Cloud for that. And I think that's the reason they are doing that. And by the way, everyone is kind of offering that, right? So you can go to AWS and they will run everything everywhere. And you can go to Azure and they call it Azure Arc, right? Where you can manage all the Kubernetes clusters, even if they're on AWS from Azure and so on. And in Google, it's the Anthos offering, right? So Anthos, you can run an Anthos Google Kubernetes cluster on AWS. But you have this added complexity and you have to understand all of that. So there's like a security layer in Azure then, and then another layer from Google coming on top of it, and then somehow it's all meshed up. But of course, within the Google Anthos, you probably don't have an Azure identity. So accessing the native services there probably again needs secrets. So you see, it gets complicated pretty quickly. So you kind of have to think about, what do I gain from it? What do I gain? Don't all the clouds these days have a way how to transfer your products from different clouds to theirs? Yes, for virtual machines and databases, not much more. If you look at these migration solutions, that's kind of what they do. And they are designed essentially to help you in getting your data center empty. Yeah. But it cannot really be done for you. And there's things that are harder than others, right? So for example, switching databases is one of the hardest things you can do. Because, yeah, you need to recode all your SQL, you need to do a data migration, you need to do a lot. I've been on multi-year projects of data migration. No joke. And what are top 3 properties based on you to select some product technology provider? I'm going to give the greatest consulting answer ever. It depends. No, but I mean, honestly. There's, by the way, very good solutions to choose each of those clouds. Not only do they have different technical properties, they also have a different culture and a different style, right? And it may or may not fit better to you or not. But with that, do we have any more? Oh, I think I still have a few minutes, right? Yes, cloud providers are spending a lot of money for support, but for pre-sales support. There's a thing I just realized that I forgot, and I wanted to speak about it. Inherently, doing something managed in the cloud is from a business logic better for both sides than you essentially getting a package of software and then installing it. Because all the classic providers like IBM, Oracle, and so on in the pre-cloud era, of course, had pre-sales people, right? And they would come to you and they would help you getting your WebSphere or WebLogic or whatever working and integrated and everything. And then the contracts would be signed and everything would be done and it would be running and they would disappear and no longer pick up the phone. but it's a bit of a joke. Of course, you get a technical support, but there's a lot on your side. The interesting thing is, if you run on the cloud, then essentially the pre-sales that is happening is essentially booked at the cloud provider, not against a one-time sale. It's booked about your customer lifetime value of your long-term consumption, right? And they want your consumption to stay high, and they want to have your consumption increase. That's also the reason why for very big spenders in the cloud, you kind of get an architect for free, right? If you're a big customer of Azure, you get a Microsoft certified architect, which you can just ask questions and he will do stuff for you. Because essentially they want to keep you happy because they're earning month by month by month by month. And I would argue that from a financial standpoint and from a motivation for them to improve their product, right, and drive simplicity, that's much better than the old model of essentially saying, well, here's the CD and here's the installation guide. Oh yeah, you have to install that specific Red Hat version. Oh yeah, and you need an Oracle database. Good luck. This model is way better than the old one from an incentive perspective. But of course, it is the ultimate way of outsourcing. Because it's outsourcing. It's not just a classic lock-in of installing a product, it's outsourcing. I think I'm on time. Right? Thanks.